Use the Lagrange multiplier method to find the maximum values of f of xy is 2x plus y minus 2z, subject to this constraint here. So we're going to call this g of x, y, and z. So what are our Lagrange equations? The gradient f is equal to lambda times the gradient of g. And then we'll also have the g is equal to 1. Gradient of f here is 2, 1, negative 2 is equal to lambda times the gradient of g, 2x, 2y, 2z. Okay, so the equations are 2 is equal to lambda times 2x, 1 is equal to lambda times 2y, and negative 2 is equal to lambda times 2z. And don't forget about x squared plus y squared plus z squared is equal to 1. Okay, so this is what we need to be solving right here. Okay, so what are we ending up with? This first equation shows us that lambda times x is equal to 1. And so let's see here, that tells us lambda is equal to 1 over x. And we can tell here lambda x, they can't be 0. We don't have to worry about that. This second one shows us that, let's see, lambda times y is equal to 1/2, or lambda is equal to 1 over 2y. And this last one here, dividing by 2, gives us lambda z is equal to negative 1. So lambda is equal to minus 1 over z. So what does this show us here? New slide. 1 over x equals 1 over 2y equals negative 1 over z. So this pair of, well, we can just take the reciprocals of everything here. X must equal 2y must equal negative z. Okay, so remember our other equations, x squared plus y squared plus z squared is equal to 1. Let's write everything in terms of y. So x is 2y, and z is negative 2y. So plop in all of this into this equation here. X is 2y squared plus y squared, z is negative 2y squared is equal to 1. 4y squared plus y squared plus 4y squared is 9y squared is equal to 1. Y squared is equal to 1/9. Y is equal to plus or minus 1/3. So this is going to give us 2 points to think about. Y can either be 1/3 or negative 1/3. X is twice y. X can be 2/3 here. If y is 1/3, x is 2/3. If y is negative 1/3, x is negative 2/3. And z is going to be negative 2 times y, or negative x. So here z is negative 2/3. If x is negative 2/3, z is 2/3. So these are the only 2 points we have to care about. And so the last thing for us to do is to plug them into this equation here, fxy is 2x plus y minus 2z, and determine min and max. Okay, so for this first case, 2x plus y minus 2z, so 2 times 2/3 plus 1/3 minus 2 times negative 2/3 is going to be 4/3 plus 1/3 plus 4/3 is 3. And for the second one, we'll have 2 times negative 2/3 minus 1/3 minus 2 times 2/3, and this ends up as negative 3. So the maximum value that f of x, y, z takes on the unit sphere here is 3, occurring at this point. And the minimum value f of x, y, z takes on the sphere is negative 3 at this point.